Okay, this next video is going to be on expectation. So expectation, as we're going to see, is kind of, well, I'm going to show it. So I'm going to be often talking about something called expected value. So there's expected value. But expected value is really just a kind of a subset of expectations. So there's lots of different expectations, of which one of them might be an expected value type situation. So for example, I'll show you an expectation. Let's say we have, this is like a wheel with an arrow, and the arrow is going to go, spinning around. So, and if it lands, we'll kind of cut the wheel in half. If it lands here, you win $500, and over here you win $1,000. So if it lands, so this is a good wheel to be spinning. So if it lands there, you win $500. If it lands there, you win on this half and this half, you win $1,000. And so the question is, how much do you expect to win? Or let's put it another way. So let's say I told you, oh, it's going to fall at the end of the spade, right? Would you pay $503 to spin? So the question is, would you pay $503 to spin this wheel? And the answer is almost certainly yes, right? Because you're going to win at least $500. So really, this wheel would be equivalent to, let's draw an equivalent wheel. Right, this wheel would be equivalent to one that looks like, so there's the spinner I'm drawing. So that'd be equivalent to one where you lose $3, that's a dollar sign. You lose $3, or you win $497. Right, so these two wheels, I can't show them at once. These two wheels, oh, there we go. These two wheels are the same, right? So, because this one I was spending $503, I could lose 3 or win $497. I'm going to do it like this just because this one has negative values, and this one is both. I mean, it's only positive, so it might be easier to follow, but it's equivalent. So what we're going to do is, the question is, would you spin it? The answer is almost certainly yes, you would spin it. We'll come back to that wheel in a second. Actually, let's go back to this wheel. So would you spend $503? The answer is maybe, well, yes. So would you spend $700 to spin this wheel? Now, the question is, I mean, obviously when I'm saying that, it's kind of emotional. Like, can you afford to lose the $200 just because you're going to win the $300? But in this course, when I'm talking about would you spend, or more, if I say should you spend, what I'm asking is a mathematical question. So what I'm asking is it mathematically appropriate to spin this wheel? And so it's, as we're going to find out, it's mathematically appropriate to spin that. It's mathematically appropriate to spin that. If it was $900, it would not be mathematically appropriate to spin it. So 503 good, 700 good, 900 not good. But emotionally, we kind of get that anyway. So let's do a different wheel. So my next wheel is going to be so that's going to be win 500, win 1,000, or win 2,000. And there's it's a spinner wheel again. And so the question is, how much is this wheel worth, right? So we're going to spin this wheel around, flick, goes around and around and around, and we either win 2,000, win 1,000, or win 500. So what it's going to do, and the question is, how much is this wheel worth? Right? And let's say, for example, I told you that it would cost $800 to spin. So is that a good deal? So would you spin this wheel? So traditionally when I've taught this class, most people actually said no for this wheel. So usually when I ask, would you spin this wheel? Most people say, no, I'm not spinning this wheel. That's crazy because half the time I'm going to lose money. I'm going to lose $300, and then here I'm only going to win $200. I mean, here I'm going to win more, but you know, that's risky. But again, this is not a socioeconomic question or a risk tolerance question. This is a mathematical question because it's a math class. And so the question is, how much is this mathematically appropriate to win? And the answer in this case turns out to be yes. And we'll get to the math in a second on that one. So the third wheel I'm going to do. So the third wheel is going to be like, so this will be example 3. And what we're going to do is, so this one over here, this one you win $500, and here you win $1,500, and it's a spinner. And the cost to spin, the cost to spin is $700. So it's $500 and it's $1,500, and the cost to spin is $700. So the question is, do you spin this wheel? Now, probably what's going to happen is you're probably going to lose $200 because you have about a 75% chance of landing on 500 and only a 25% chance of landing on 1,500. So the question is, should you spin this wheel? And generally speaking, when I ask people this question, the response is usually no. They would not spin this wheel, right? They're probably going to lose. People don't like probably losing, or they think they don't like probably losing, so they're not going to spin this wheel. But again, we'll find out whether or not it's worth it in a second. Let's go back to the first wheel. Actually, first we're going to have a formula. So we're going to have a formula for expectation. The expectation formula. And I'm going to use this notation. It's going to be a summation thing. So we're going to go off to, we're going to have another side kind of point here before we do that. A summation notation. So summation is this thing over here, and that's it's actually a capital sigma, and that essentially means add them up. Right, so if I have, for example, the sum of x, that means add up the first value of x, and add up the second value of x, and add up the third value of x, and add up the fourth value of x, and add up the fifth value of x, and so on and so forth. If I had the summation of x squared, that'd be take the value of the first x, square it, plus take the value of the second x, square it, plus take the value of the third x, square it. And you could do lots of things. And there's a lot of interesting math with summations that they don't cover in high school because it would be a lot too much fun. So, the expectation formula is essentially the summation of x px. So we're going to have a function e of x, and don't worry about me saying function. I'm not going to say that much. So E of x, that's our expectation, is going to be the sum of the values times the probability of getting those values. Or another way of writing that would be, we're going to take the first value and we're going to multiply it by the probability of getting that value, plus the second value, and we're going to multiply it by the probability of getting that second value, plus the third value, and multiply it by the probability of getting that third value, plus the fourth value, and the probability of getting the fourth value, plus, and we get the point. It goes on and on and on. And that's our expectation formula. And so we're going to have to figure that one out. Okay. So let's go back to wheel number 1. And we are almost out of space. So what we're going to do is we're going to take, so remember, the formula is that we need the x values and we need the probability. So we need the value and the probability of getting that value, which is, so we need a value and we need the probability of getting that value. So the values we could get on this wheel, x is going to be how much we win. So we could get 500 or 1,000. And the probability of getting 500 is 50% in this wheel. And the probability of getting 1,000 is 50%. So, and then if you look at the formula, what do? We need to multiply the value times, by the way, do we recognize this? This is a probability distribution. This is a list of the probabilities of all the possible outcomes. What do you know? So in this formula, we need to take the x and multiply it by the probabilities. So that's what we're going to do. We're going to take the x values. We're going to multiply it by the probability of getting those values. So we have our x, p of x, and x times p of x. So 500 times 0.5 is 250. 1,000 times 0.5 is 500. And then what do? We take those x, p, x values and we add them up. So we add them up and we get that this wheel is worth $750. So this, we expect to win $750 when we spin this wheel once. Are we going to actually win $750? Not a chance. We are going to win 500 or we're going to win 1,000. We are absolutely not going to win 750, but we expect to win 750. So we're not going to win $750, but we expect to win $750. So would you pay $503 if you expect to win $750? Yes. Would you spend $700 if you expect to win $750? Yes. Would you spend $900 if you expect to win $750? No, you should not. Okay, wheel number 2. So if we're going to set up a, how long is this video getting right now? It's getting a bit long. If we're going to set up the XPX chart, x p of x, x p of x. So the x values can be 500, 1,000, or 2,000. The probabilities would be 0.5, 0.25, 0.25. This times this is 250. This times this is 250 as well. And this would be 500. We add them up. And we get that the wheel is worth $1,000. Are we going to win $1,000? Maybe. So we expect $1,000. Is it worth $800 to spin this wheel? The answer is yes, it is. Okay, last example I'm going to do on this video. So this one over here, this is the one that's a little maybe obvious, maybe counterintuitive, I'm not sure. So the question is, what's the cost? So the cost to spin is $700. You have a 75% chance of essentially losing $200 and a 25% chance of winning $800. And so the question is this wheel worth it? So we're going to set up our XPX table. X times P of X. So X could either be 500 or 1,500. And the probability of getting it is going to be 0.75 and 0.25. And 500 times 3/4 is what? Yes. I'll just double check it. Sometimes when your mistake is going to be preserved in video forever, it's best to be on the safe side. 375 and 1500 times 0.25 is also 375. So 375 plus 375 is $750. So we expect to win $750. I'm going to write this out because this is kind of important. So we probably will win 500, but we expect to win 750. So notice, expectation isn't, it may sound like expectation is most likely, but that's not what expectation is at all. Expectation is essentially an average. So we're probably going to win 500, but we expect to win 750. So the question is then, would you spend $700 to spin this wheel that you're probably going to lose, but you expect to win? And the answer is that of these two, this is the one that matters. What matters is your expectation. As long as you follow expectation, on average, you will end up with more money. This is a kind of a short-term thing. This is the long-term thing. So if you spin the wheel once, you expect to win $750, even though you have no chance of actually winning $750, but you're probably going to win 500. But because you expect to win more than the cost, then you should pay, and you should spin. There we go. Okay, I said I was going to end the video after this example, but I am going to do one last crazy thing. Not crazy. One last wheel. So here's a wheel that sometimes people buy, or spin, I guess I should say. And generally, and this wheel is win 0, so win absolutely nothing. And then this one is win something like 500 bucks. Okay, that's hard to see. So it's win 500. That's what it says over there. And so the question is, would you spend, I don't know, 180 bucks to spin? And the answer, of course, is you have to be crazy to spin this wheel. But there's a name for this wheel that gets people to actually go and spin it. And they call this wheel extended warranty. Because what are you probably getting with an extended warranty? Absolutely nothing. With a small chance of maybe your product breaks and you get your money for it. And people, not only do they spin this wheel, they spin it over and over and over. So, that's it for that. We'll go on to non-wheels in the next lesson.